So flip backwards to, well, actually only one page backwards, because we're going to do U14 notes together, and then we'll back up a little bit more, and the 2 pages before that will be today's assignment. So find U14 notes. Well, and there's the notes to myself, exactly what we're going to do. We're going to do 1, 3, 5, and then we'll do number 5 off of worksheet 3. So these are the practice problems. We don't need to do all of them to get a feel for what's going on here. So number 1, a triangular parcel of ground has sides of 725, 650, and 575. Find the measure of the largest angle. So one approach would be to just find all the angles and then circle the largest one. A better approach would be to know where the largest angle is. That way I only have to find one. Yeah, we've said this a couple times. The biggest angle's across from the biggest side and the smallest angle's across from the smallest side. So the largest angle is going to be across from the biggest side. So there would be my largest angle. So that's the one I'm looking for. This doesn't have any letters on it, and I guess you could do this problem without any letters. I'm just going to label it ABC because that helps me pick a formula. So I want the formula that has cosine of A in it, which means I need A squared on the other side. Sides and angles are across from each other in the picture and across from each other in the formula. And I guess I really don't even need to label the other sides because I'm just using the other two in here. So 650 squared minus 575 squared minus, running out of space, 2 times 650 times 575 times cosine of A. So I'm going to pause it. You see if you can do your algebra to move things around, and then inverse cosine and see if you can figure out what angle A is. That, yes, a mistake. Some of you caught it here. Hope you saw it at home. That should be plus. A squared plus, well, these two are added and then that one's minus. So now try the algebra on it. So you rearrange things into this. Or, as some people here have done, they've just either intentionally memorized that formula or used it often enough to where they can just write it like that, and that's completely okay. And if you do that, then maybe it makes the calculator easy because you can go straight there. Inverse cosine of, and then the fraction bar. And you just get it all at once. Angle A is 72.281. Again, unless otherwise specified, go to 3 decimal places. It's just good practice for the AP test next year, which hopefully some of you will take. Questions on that one? I mean, yes, it's a word problem, but most of these word problems, it's so clear as to what they give you and what they're asking for, it's not really difficult. Number 3, to approximate the length of a marsh, a surveyor walks 250 meters from point A to point B. Okay, 250 meters from point A to point B. Then turns, so he's not like continuing in a straight line, and walks 220 meters to point C. I don't really know where that is, so I'll just put a C on there somewhere. If the measure of, oops, the little angle symbol didn't show up there, but if the measure of angle ABC is 105, ABC is 105, find the length of the marsh. So this one I'd say is a little bit confusing. It's like, well, it didn't tell me exactly where the marsh is, but surely it means like this is the marsh right here, like there's some wetland area, and what we're really finding is the length of that marsh, because what else would we be finding? So let's see, those two make me think law of sines, but I don't know both of those. So law of sines only works if you know an angle-side pair, and we don't have that. So this is going to be law of cosines. The other way to see it is this is a side angle side problem. So that's a law of cosines problem. We're looking for side B, which means we need to use angle B, which we know angle B, and we know all of them. So this is the straightforward law of cosines. I'm not going to say law of cosines is easy, but as far as law of cosines problems go, this is about as easy as it gets. As always, don't forget the square root. But fortunately, when you're working with big numbers, surely you wouldn't say the length of the marsh is 139,000 meters. That would seem a little bit extreme. 373 seems reasonable, especially given that was an obtuse angle over there. Questions on that one? Pretty straightforward. Number 5. Then we'll do one off the actual assignment together. A man sees a window washer. The man is 150 feet from the building, and the angle of elevation is 23 degrees when the man first spots the window washer. Okay, so here's my man down there staring up at the window, or staring at the window washer. The angle of elevation, again, if you're looking straight out, your angle of elevation is 0. As you lift up, that's what increases your angle of elevation. So at first, we'll just assume like the man is like laying on the ground looking up, so we don't have to worry about his height. So the first glance, that angle of elevation is 23. Find how far the window washer moved if the man sees the same window washer 2 hours later from the exact same spot with a new angle of elevation of 79. So we want to know that height from A to B. So I could figure out this angle, but I don't know that helps me a whole lot. Well, let's find this angle. Let's work it as a law of sines problem, I think. So 79 minus 23, that angle would be 56. I guess the problem is if I want to use this triangle, I don't have any side links in that triangle. So this is a multi-step problem, however I'm going to work it. I kind of want to use this triangle because I want to find h. And I'm thinking law of sines because I've got 56 and h. That's the law of sines type thing. But I don't know any other lengths.
But, yeah, isn't that like a right triangle?
It is. And so maybe the easiest way is to just say this is length A and this is length B, and then just subtract them and do two separate triangles. So I think that's the way to go. Because if you want to use the one triangle, that's fine, but it takes some work to get there. And so it's probably just as easy to work the big right triangle and the little right triangle and subtract B minus A. I think that's probably the easiest way to go. So I'm going to run out of colors again. Looking at the little triangle, I want to find side A. This is good review stuff here. So looking at just the green triangle, what kind of equation could I write that involves A and 150? If I know 23, A is the opposite, 150 is the adjacent. I could do tangent. So I can say the tangent of 23 equals opposite over adjacent. So A is 63.671. Not my final answer, but helpful. Next I need to find B, so I'll look at the outside triangle, the big right triangle. And it's kind of the same process. Although now I've got three angles labeled down here. Which one do I want to use if I want to do B over 150? Yeah, 79. I want to use the full angle. I got a lot of angles down there, but 79 is the angle in the triangle. So tangent of 79 equals B over 150. So 150 tangent of 79. That's really big. 771.683. That window cleaner is way up in the air. Then my answer is just B minus A. 708.012. And again, there are different ways to work that problem because there's so much information, and it's like three triangles there: the little one, the top one, and the overall one. There's multiple ways to get there, but I think that was the most straightforward way to get there, to do it. All right, today's assignment, and we'll do one together. So now back up a page. There's part of it. So worksheet 3, but we're not going to do the very first page that says derive the law of sines and derive the law of cosines. It's possible, it's not difficult, but we don't want to mess with that. So our assignment today is those 7 word problems, but I want to do number 5, mainly because I don't really like the picture, so I didn't think it was clear enough. So we'll do 5 together. The roof of a house is at a 20-degree angle. An 8-foot solar panel is to be mounted on the roof and should be angled at 38 degrees relative to the horizontal for optimal results. So for whatever reason about where the sun is and where you are, on the Earth's latitude, like how do you need to position your solar panel to get the maximum sun? And for this particular one, it needs to be 38 degrees from horizontal. I guess the tricky part is the roof is already 20 degrees. How long does the vertical support, so this piece right here, holding up the back of the panel, need to be? All right, again, the picture looks a little bit funny, so I'm going to try to redraw the picture here. So there's the roof at 20 degrees. Here's the panel. What's that angle inside that the panel makes with the roof? Because that's not 38. Do you know what that angle is? This inside angle right here? That should be 18. 38 minus 20. Vertical support is H, and the thing is 8 feet long. And so I'm thinking law of sines because I got those two. Well, I don't have that one, so I can't use law of sines yet. Be nice if I knew another angle. So that's a right angle, but that angle's not in my picture, so that doesn't help. What about this angle? Can we figure out what that angle is? Yeah, that's 90 minus 38, which is 52. And so even though we sort of messed with the bottom part of our triangle, that's still 52 up there. And again, this is the triangle I really want to focus on. And if I know two of the angles, that means I can find the other angle. 52 plus 18 is 70. So that little angle is 110. This is just using lots of geometry, and this happens on some of this 6 and 7, especially on this assignment. So now I'm good to use law of sines because I've got 8 and 110. So sine of 110 degrees over 8 equals, let's see, I want to use the h. I want to find h. So sine of 18 for h. That's enough to show. I'm really going to show one more step just so I don't mess up the algebra. 8 sine 18 divided by sine of 110. So 2.631. Careful on units, just make sure you're consistent in here. This one was in feet. 2.631 feet for number 5. All right, so that only leaves 6 of them for you to do. I would recommend going back and starting at number 1, because number 1's pretty easy, 2's pretty easy, 3's not hard, and then you start to get into a little more geometry stuff with 4, 5, 6, and 7. But they go pretty quick, at least initially. Answers to all are posted in Schoology, or if you guys are in the room, they're right up here on the table. So shouldn't be too difficult to knock some of them out before you leave. Tomorrow, again, we'll do area of triangle. That'll be the last new day of stuff. And then we'll just do word problems review, until we get to the test next week.